So we'll carry on with our discussion of wireless standards. We've just talked about 802.11b and 802.11a. And even though 802.11a was the first amendment to the plain 802.11 standard, it was not nearly as popular as 802.11b. And you might look at it and say, well, why isn't it as popular? Yeah, it uses a higher frequency band and you might have to have more access points, but you've got more channels, you've got a higher data rate, and it was around first. Why isn't it more prevalent than it is? I mean, you can hardly find any type of 802.11a networking equipment out there. The reason why is that 802.11a hardware was only used by early adopters, mainly in a corporate environment where interference wasn't nearly as much of a problem. If you had interference or you had signal loss, you just threw another access point in place. This being the first iteration of the standard that was different from the 802.11 naked standard, I guess, is the best way to term it. The hardware was awfully hard to come by. Everyone was buying just a plain old 802.11 hardware. Not a lot of people were buying the A hardware because it was different, it was more expensive, and again, it didn't get as good a range, so at least for most smaller businesses that may have wanted to put in a wireless network, they'll just use the plain 802.11 standard. It's not as fast, but it gets the job done just as well. However, when 802.11b was introduced, since the hardware is pretty much the same as 802.11, the sales of 802.11b hardware pretty much took off because you had the same frequency usage and some of the same channels as 802.11, but you had a much higher data rate, again, from 1 to 2 all the way up to 11, which means that the corporate people that had already used 802.11 didn't have to buy more access points. They could basically just do a firmware upgrade to their existing access points, and they could run 802.11b. And that's why the 802.11b hardware kind of eclipsed the 802.11a hardware, even though the A hardware was around first. So anyway, that's the whole sordid story behind 802.11a versus B. Again, one's not any better than the other unless you just look at the raw data speed. But it was just a matter of getting the hardware to market quickly enough. So let's move on to what is probably the most commonly used and most popular wireless network standard out there, 802.11g. 802.11g is almost identical to 802.11b. It uses the 2.4 gigahertz band like 802.11b, but it uses the transmission scheme from 802.11a, therefore allowing you to use more of your channel bandwidth and use it more efficiently. It is fully backwards compatible with 802.11b hardware, so there was no manufacturing changes that had to be made. The same antennas, the same chipsets, everything worked with 802.11b and 802.11g. And in fact, I remember when the G hardware first came out, it was literally a firmware upgrade to the wireless access point I had in use at the time at the small company I worked for. 802.11g allows for 14 channels and allows data rates up to 54 megabits. So as you can see, you've got the best of both worlds between the 802.11b and the .11a standard. You're using the 2.4 gigahertz bands, which has a greater penetration and not as susceptible to interference, at least absorption and scattering, although you had other devices that use the 2.4 gigahertz band. However, you can get the higher data rates that the .b standard gives you. And last but not least, we'll talk about the new kid on the block, the 802.11n standard. And it's fairly new. It's been out for a couple of years, and there are already devices out there that can use the N networking standard. 802.11n has the ability to use both the 2.4 gigahertz and the 5 gigahertz frequency band, depending on which is least used for the installation where you have it. 802.11n allows for speeds up to 600 megabit, which greatly enhances its usability in a corporate network where you have to move large files around on a pretty alarming basis. 802.11n accomplishes this by basically using two antennas, where a lot of the G and the A and the B access points only had one. The 11n access points have at least two. And so you use one for transmission and one for receive, and by doing that, you'll overcome the limitations of that half-duplex connection that we mentioned way back at the beginning of all of this. Now again, the .N standard is not on the exam, and so I'm just going to cover it very briefly like we just did. But I didn't want people to watch this video and go, well, gee, this video is 7 years old. What are they talking about 802.11n for? And so just to set your mind at ease, it's not the course that's old, it's really the source material that Cisco gives us. And that concludes our discussion of wireless concepts and standards.